I want you to just picture the far northwest of Scotland for a second. We are standing on the Durness Peninsula.
Oh, yeah, it is a truly wild place.
Right. It's incredibly rugged. It's just completely windswept. The weather there, it doesn't just happen around you. It kind of actively fights you.
Yeah, that's a good way to put it.
You have this icy swell of the North Atlantic just crashing against these sheer cliffs. And then you have these rolling stretches of this very specialized alkaline sand dune environment. It's known as Mashare.
Right. The Mashare is crucial to this whole story.
It really is. So we're at the absolute edge of the Scottish mainland. The year is 2000. And out of this low, really unassuming mound of stones at a place called Loch Borralie, a human skull just rolls out.
Literally just pops out.
Yeah, it literally erodes right out of the hill and down the slope.
Which is, it's the ultimate dramatic inciting incident for any archaeological investigation. That single skull just sort of emerging into the daylight in the year 2000, it acted as a massive catalyst. It set off this whole chain of events and, well, scientific inquiries that would fundamentally rewrite our understanding of Iron Age Britain.
Which is the exact core mission of our deep dive today. We are unpacking a truly mind-bending, just massive, multidisciplinary study that was conducted by the COMIOS project.
Right. COMIOS is fantastic.
Yeah. For those following European archaeology, COMIOS is this incredibly ambitious initiative. I think it's funded by the European Research Council, right?
Yes, exactly. Their primary focus is basically mapping the demography and the funerary archaeology of Iron Age Britain.
Right. So they took this 2,000-year-old cold case involving an adult woman and a teenage boy found at Loch Borralie, and they just threw a staggering arsenal of modern science at it. We're talking osteology, multi-isotope analysis, ancient DNA, the works.
And that's so important because finding any human remains from this specific era is a massive anomaly. It's incredibly rare.
Right, because of the invisible dead thing.
Exactly. When we discuss Iron Age Britain, so a period stretching roughly from 800 BC down to the Roman incursions around AD 43, we run into this really frustrating paradox.
We see their stuff, but not them.
Right. We see their fingerprints literally everywhere. We find these monumental stone towers, which are called brocks. We excavate their roundhouses. We map out their agricultural terraces. We find all their discarded tools. The landscape is just heavily marked by human habitation.
Yeah.
But the people themselves, the actual physical remains of the dead, are, for the vast majority of the British Isles, archaeologically invisible.
Archaeologically invisible. It's almost eerie to think about,
It really is.
You have this thriving, building, farming society, but the bodies are just gone. And I've read that this comes down to a mix of soil chemistry and cultural practices. Right?
Yes, it's a combination of both. So most of the soil in Britain, particularly in the highland and peatland areas, is highly acidic. And unless a body is deposited in a highly specific anaerobic environment like, a peat bog, which creates those famous leather-like bog bodies.
Oh, yeah, the bog bodies are wild.
They are. But outside of that very specific environment, acidic soil will just dissolve bone completely over a couple of millennia. Calcium phosphate simply cannot survive those pH levels for that long.
So the earth literally just eats the evidence.
Basically, yeah. The soil chemistry absolutely plays a massive role in that erasure. But the cultural component is just as significant because, except for a few highly specific regional anomalies...
Like what?
Well, like the Eris culture cemeteries over in East Yorkshire. Those appear right at the end of the Iron Age.
Right.
But outside of those exceptions, these communities simply did not utilize formal cemeteries.
Right.
They weren't digging deep graves and burying their dead in neat, recognizable rows that modern archaeologists can just come along and easily identify.
Which leaves us with a lot of theories about what they were actually doing with the bodies. If they aren't burying them, maybe they are practicing excarnation.
Yes, that's a leading theory.
Like leaving the deceased exposed on platforms or in secluded areas for scavengers in the elements to just strip the flesh away, and then perhaps they were scattering the remaining dry bones. Or maybe they were cremating the dead and just casting the ashes into rivers.
Exactly. The really frustrating part is that an absence of evidence leaves us completely in the dark. We just have to guess.
Which is why this site is so incredible. Okay, let's unpack this. Because what that alkaline sand preserved at Loch Borralie is not a story of a peaceful passing.
No, not at all.
We are going to examine evidence of targeted, high-velocity cranial impacts. We are going to look at the intentional surgical removal of a human brain. We are diving into the microscopic analysis of long bones that were systematically stripped of flesh and whittled down to sharp points.
It gets intense.
It really does. And then, taking all of that trauma, we are going to look at a genetic map that proves these prehistoric people were incredibly mobile. They were navigating these treacherous oceans and maintaining highly complex family networks over hundreds of kilometers.
Yeah, it really forces us to hold two seemingly contradictory ideas in our heads at once.
How so?
Well, on one hand, we have this evidence of extreme catastrophic violence and bodily mutilation. But on the other, we have undeniable evidence of profound community reverence, curation of the remains, and a deeply physical, sustained interaction between the living and the dead.
Right. They didn't just throw her away. But before we get into the post-mortem brain removal, we have to start at the physical scene. Let's look at the architecture of the burial itself. If we are going to understand what happened to these two people, we have to understand the specific context of where they were placed.
Absolutely. So the site is officially designated as the Loch Borralie cairn.
Okay.
And in Scottish archaeology, a cairn is broadly defined as a deliberately constructed mound of rough stones. It usually serves as a burial monument or sometimes a navigational landmark.
Okay.
However, the structure the archaeologists encountered in 2000 was not some towering, pristine monument. It was a very low, highly disturbed spread of stones sitting on this shallow natural slope. The footprint measured roughly 7 meters on its north-south axis and about 3.5 meters east to west.
That's a relatively modest footprint. I mean, we are talking about an area roughly the size of 2 parking spaces side by side.
It's not massive. And the vertical height was only about 1.2 meters at its peak.
Oh, so it's barely waist high.
Exactly. And the modest size is partly due to centuries of later human interference. Throughout the subsequent centuries, particularly during the agricultural shifts of the highland clearances, local populations really needed stone to build field boundaries and sheepfold.
Oh, right.
Yeah, so a prehistoric burial mound is, from a purely pragmatic standpoint, a very convenient pre-gathered quarry.
Why go dig up new rocks when there's a pile right here?
Exactly. It's a classic taphonomic issue. Later human activity destroys the earlier stratigraphy.
Right, but despite the stone robbing, the core of the cairn remained intact enough for the 2000 excavation team to carefully peel back those surviving layers. And underneath, they didn't just find a jumble of bones, they found 2 distinct, deliberately placed individuals.
Yes. The stratigraphy, the layering of the deposits, revealed a really clear sequence of events. So the primary burial, which we designate as individual 1, belonged to an adult female.
Okay.
Osteological analysis of her pelvic structure, her cranial sutures, and her dental wear indicated she was well over 30 years old at the time of her death.
And how was she placed?
She was positioned on a small primary mound of stones that formed the foundational layer of the site.
The burial posture is always a massive clue to the cultural mindset, right? I read she was found in an extended supine position.
Yes.
Meaning she was laid flat on her back, fully extended, with her head oriented toward the east. And that orientation often has solar associations in prehistoric contexts, right? Like facing the rising sun.
That's the standard interpretation, yes.
Yeah.
And the material culture placed with her further indicates a formal, considered funerary rite. She wasn't simply discarded in a ditch.
Right. They found some stuff with her.
They did. The excavation recovered a crude quartz strike associated with her remains.
Just for making fire, right?
Exactly. Quartz strikes were fundamental survival tools. You'd use them in conjunction with iron or pyrite to create sparks for fire starting.
But more telling than the quartz, I think, was the Iron Age ring-headed pin they found with her.
Oh, absolutely.
Because finding metalwork in these Machère burials is rare. The alkaline sand preserves bone, sure, but the aerated, salty environment is incredibly corrosive to iron and bronze.
It destroys metal, yeah.
But the presence of that pin is a strong indicator of clothing, right? She was likely dressed in a woven garment, or perhaps wrapped in a specific funerary shroud, and that pin was used to secure it at the shoulder or chest.
Precisely. The presentation of individual 1 shows undeniable care. And then, just a short distance away from her, within the footprint of that same monument, the team found individual 2.
Ah, the whistleblower skull.
Ah, exactly. The one that rolled down the hill. Individual 2 is a juvenile male. The osteologist looked at the eruption of his second molars and the fusion state of his epiphyses.
Epiphyses being what?
Oh, sorry. Those are the growth plates at the ends of the long bones.
Yeah.
Based on those specific developmental markers, his age at death was narrowed down to a very tight window of 14.5 to 15.5 years old.
Wow, that is really specific. And the placement of the teenager is slightly different from the adult woman, right?
It is. He wasn't laid out on a primary stone platform like she was. He was placed in a more traditional grave cut, basically a shallow pit dug right into the underlying Machère sand.
Okay.
And based on the way the soil and the stones overlap, it seems his grave cut was made slightly after the woman was placed on her stern platform.
So the stratigraphy suggests a staggered timeline, but a deeply connected one. Like both individuals were placed at this specific location, and then eventually the broader community gathered massive amounts of rough stone to construct the overarching main body of the cairn, sealing both of them beneath a single monument.
Exactly. Determining the absolute chronology of when this happened was the next major hurdle for the Kamios team.
Right, they need a date.
To get a precise window, they utilized accelerator mass spectrometry, or AMS radiocarbon dating.
And for anyone who follows archaeology, AMS is just a massive leap forward from the old school radiocarbon counting methods, right?
Oh, it's night and day.
Because instead of waiting for the carbon-14 atoms in the bone collagen to naturally decay over months and trying to measure those faint radioactive emissions, which takes a huge chunk of bone and forever to do, AMS uses an actual particle accelerator.
It's wild technology.
It literally separates the atoms by weight and counts the individual carbon-14 isotopes directly, so it requires a tiny sample, like a single tooth, and gives a much tighter chronological window.
It does. And the precision of the AMS dating on the Loch Borralie remains provided a remarkably consistent series of dates. The results for both the adult female and the teenage boy firmly place their deaths between 50 BC and 80 70.
Man, that specific 120-year window is one of the most turbulent, transformative periods in the history of the British Isles.
It really is the end of an era.
We are looking at the absolute twilight of the indigenous pre-Roman Iron Age. I mean, by AD 70, the Roman legions have already conquered the southern and central parts of Britain.
Yep.
And in just a few years, around AD 79, the Roman general Agricola is going to launch his massive military campaigns into northern Scotland. He's pushing deep into the Highlands and eventually clashing with the Caledonian tribes at Mons Groupius.
Right, so these two individuals lived and died in a world that was entirely Iron Age in its culture, its politics, and its daily realities. But the shock waves of the expanding Roman Empire were likely already radiating up the coastlines, through trade networks and displaced refugees.
It's a heavy context. And we established earlier that the default setting for Iron Age burials is invisibility. The bodies are usually gone. But here, the bodies are highly visible, deliberately positioned, equipped with tools and shroud pins, and memorialized under a stone monument.
We have the physical text, essentially.
Exactly. We have the text. Now we need to read what the bones are actually saying. And that requires us to pivot from the serene image of an east-facing burial shroud to the incredibly violent, chaotic moments that ended the adult female's life.
Yeah, the osteological analysis of individual one, the adult female, it reveals a sequence of trauma that is, honestly, difficult to process.
Where did they start?
The researchers focused intense scrutiny on her cranium. When they examined the basal region, so the complex architecture of bones that form the floor of the cranial vault and connect the head to the cervical spine, they documented a catastrophic structural failure.
Okay, let's ground this in anatomy so we can visualize the damage. Because the base of the skull isn't just one solid bowl, right? It's a mosaic of interlocking bones.
Correct.
For individual one, the researchers noted that the condylar and basilar parts of her occipital bone,
which is the heavy bone curving under the back of the head that houses the foramen magnum.
Right, the hole where the spinal cord exits. So those parts were completely detached from the rest of the skull. Furthermore, a portion of the sphenoid bone, which sits deeper inside the base of the skull right behind the eyes, was also fractured and detached.
It was a massive injury. And the immediate critical question for any osteoarchaeologist looking at a crushed skull from antiquity is distinguishing between taphonomic damage and perimortem trauma.
Right.
Taphonomic damage occurs long after death. So perhaps a heavy boulder shifted inside the cairn centuries later and crushed the brittle skull.
Makes sense.
But perimortem trauma occurs at or around the exact time of death.
Wait, how can researchers tell the difference between a bone breaking when someone is alive versus a skull just getting crushed by rocks over 2,000 years later? That feels like it would look exactly the same.
It really hinges on the structural properties of what we call wet bone versus dry bone.
Okay, break that down for me.
The terminology wet and dry refers to the organic content of the osseous tissue. Living bone, or bone from a recently deceased individual, is fundamentally a composite material.
It's not just chalk.
Right, it's not just dry rock. It has a rigid mineral matrix of calcium phosphate, sure, but that matrix is heavily intertwined with organic collagen fibers, blood, lipids, and moisture. This organic component gives living bone a surprising amount of elasticity. It can actually absorb kinetic force, bend slightly, and deform before it finally fails and snaps.
Okay, so when wet bone does fail and break, it leaves a very distinct signature.
Exactly. Because it's elastic, it tends to tear or shear. The edges of a wet bone fracture are usually smooth, and the angle of the break is often oblique.
Okay.
Furthermore, the color of the fracture margin will perfectly match the color of the surrounding cortical bone, because the interior was exposed to the same soil environment at the exact same time as the exterior.
Conversely, dry bone has lost all of its collagen and lipids through the process of decomposition over hundreds of years. It is purely the brittle, mineralized matrix.
Right, so if a heavy rock falls on a dry skull, the bone cannot deform or absorb the energy at all. It simply shatters. The fracture edges will be jagged, rough, and typically snap at stark, perpendicular right angles.
It's the classic analogy of breaking branches.
Oh, that's a perfect analogy.
If you bend a fresh green branch right off a living tree, it resists, it splinters, and it leaves a frayed, angled tear. But if you step on a dead, dry branch lying on the forest floor, it snaps instantly with a clean, sharp break.
Exactly. And when the osteologist examined the detached cranial base of individual 1 under magnification, the morphology of the fractures exhibited all the classic indicators of wet bone failure.
So it broke like a green branch.
Yes. The margins were smooth and angled. And crucially, they observed radiating linear fractures extending outward from the primary points of failure. Dry bone does not produce radiating fractures because it cannot transmit kinetic energy through an elastic matrix. Therefore, the scientific consensus is absolute. This massive detachment of her cranial base occurred while the bone was still fresh. It happened at or immediately surrounding the time of her death.
Wow. Okay, so establishing that the trauma happened when she was alive is step 1. Step 2 is figuring out the mechanism. How does the base of your skull completely detach from your spine? You can't just bump your head to cause that.
No, you really can't. The researchers turned to modern clinical and forensic data to find comparative models. In contemporary trauma wards, basal skull fractures of this severity are generally the result of extreme high-velocity blunt force impacts.
Like what?
We see them in victims of high-speed motor vehicle collisions, catastrophic industrial accidents, or highly violent interpersonal assaults.
Well, given that we can safely rule out motor vehicles in 50 BC, the researchers had to test other potential mechanisms. I've read some clinical literature on executions, and the first thing that comes to mind is a hanging. Could a rope do this?
It's a logical thought, and the researchers tested the execution hypothesis. Specifically, they looked at a long drop hanging, where the body falls a significant distance before the rope snaps taut.
Right.
That specific mechanism produces a very well-documented injury known as a hangman's fracture. This is technically a bilateral fracture of the pars interarticularis of the C2 vertebra, which is the axis bone in your neck.
So it breaks the neck bone itself.
Exactly. The force violently hyperextends the neck and snaps that second vertebra. Individual 1 did not have a hangman's fracture, and the specific detachment of her occipital condyles just does not align with the biomechanics of a hanging.
Okay, if she wasn't executed by hanging, what about a fatal fall? The terrain in northwest Scotland is incredibly treacherous. What if she slipped off a sea cliff?
A fall from a significant height was also thoroughly evaluated. When a human body falls and lands on its feet or the base of its spine, the kinetic energy creates an immense axial load.
Axial load meaning the force travels straight up.
Right. The force travels straight up the vertical column of the spine, heavily compressing the vertebrae and eventually slamming the top of the cervical spine straight up into the base of the skull.
Ouch.
Yeah, and this can indeed fracture the cranial base. However, axial loading almost always produces severe, recognizable compression fractures in the lower thoracic and lumbar vertebrae, as the spine acts like a shock absorber taking the brunt of the impact. Individual 1's vertebral column did not show the compression damage consistent with a fatal vertical fall.
So no hanging, no axial loading fall. By meticulously testing and ruling out these specific scenarios, the clinical biomechanics point toward a really chilling conclusion. The fracture pattern most closely aligns with a direct, high-velocity targeted impact. She was struck with tremendous force by someone or something.
And the osteological record of violence does not end at the cranium. When the team examined her postcranial skeleton, specifically the scapulae, her shoulder blades, They discovered severe, unhealed trauma.
The shoulder blades are robust bones, though. They're heavily protected by thick layers of muscle. To break them requires significant force.
It does. The researchers identified bilateral fractures at the base of both scapular spines.
Bilateral?
Yes. Bilateral means the trauma occurred on both the left and right sides simultaneously.
Oh, wow.
And like the skull, these fracture surfaces were smooth, they exhibited areas of wet bone splintering, and they showed absolutely zero signs of osteological healing or remodeling. These are unequivocally perimortem injuries.
Just try to conceptualize the biomechanics of an event that causes your skull base to completely shatter and detach while simultaneously snapping both of your shoulder blades with no time for the body to even begin the healing process.
We aren't talking about a simple brawl or a domestic dispute.
No, we are looking at a highly complex, overwhelmingly violent event. Whether it was a coordinated assault with heavy blunt weapons or being trampled by a massive animal like a horse or a bull, she was subjected to catastrophic physical destruction right at the end of her life.
The sheer brutality of the perimortem trauma is shocking. But the violence of her death is only the prologue to the mystery of Loch Borralie.
Right.
The narrative shifts abruptly from a violent Iron Age demise into a realm of post-mortem mortuary processing that is incredibly rare, deeply unsettling, and technologically fascinating.
This is where we leave the emergency room forensics and enter a much darker, highly ritualized space. The researchers didn't stop at examining the exterior fractures of the skull. They used endoscopic tools and lighting to examine the endocranial surface, the actual inside of the cranial vault.
Specifically, they focused on the internal surface of the frontal bone. That's the area that sits directly behind the forehead and houses the frontal lobes of the brain.
Okay.
On that internal concave surface, they discovered a distinct series of straight, parallel striations deeply cut into the bone.
This is where the rigorous application of the scientific method becomes so paramount, because finding microscopic scratches on a bone that has been buried in coarse-machair, sand, and rubble for 2 millennia is not immediately proof of human activity.
Right, dirt is scratchy.
Exactly. The soil is a highly abrasive environment. How do osteoarchaeologists separate the noise of 2,000 years of dirt from the signal of deliberate human modification?
They utilized taphonomic analysis. As we touched on earlier, taphonomy is the study of everything that happens to an organism between the moment of death and the moment of discovery. You have to systematically hypothesize every natural process that could scratch a bone and test the physical evidence against the known signatures of those natural processes.
Okay, let's run the taphonomic gauntlet. Hypothesis 1, trampling. The grave was shallow, it was disturbed over the centuries. Maybe animals or humans walked over the site, grinding the sharp edges of the coarse sand and gravel against the interior of the broken skull.
Trampling is a highly common taphonomic factor. However, the mechanics of gravel being ground into bone under varying weight loads creates a very specific pattern. The resulting scratches are superficial, they vary wildly in depth depending on the pressure of the footstep, and crucially, their trajectory is entirely irregular. They basically crisscross randomly.
Okay, so it looks like a mess.
Yeah. Furthermore, the cross-section of a trampling scratch under a microscope is usually a symmetrical U-shape caused by a rounded grain of sand rolling. The striations inside individual one's skull are deeply incised, distinctly straight, parallel to one another, and highly consistent in their depth. Trampling simply cannot produce that level of geometric organization.
Okay, hypothesis 2, biological erosion. We know the soil is full of microbes, fungi, and insect larvae that secrete acids or physically bore into bone to consume the residual collagen. Could bugs have done this?
Microbial bioerosion is ubiquitous, but the scale is completely wrong here. Microbes and fungi leave microscopic tunneling and focal destruction that is generally only visible under a scanning electron microscope. The parallel striations on the frontal bone are macrovisible. You can see them clearly without high-powered magnification.
All right, hypothesis 3. Root etching. Plant roots secrete humic acids as they grow through the soil in search of nutrients. When a root grows against a buried bone, the acid etches a channel right into the surface.
Root etching is perhaps the most frequently encountered bone modification we see, but roots follow the path of least resistance. They meander, they branch out in dendritic tree-like patterns, and they do not grow in perfectly straight parallel lines. Moreover, the physical morphology of a root trace is imbricated.
Imbricated.
Yeah, meaning the etched channel overlaps itself in a pattern resembling shingles on a roof. The marks inside the cranium are distinct, continuous, parallel linear incisions, not overlapping rude traces.
So, by systematically ruling out the erratic scratches of trampling, the microscopic tunnels of fungi, and the meandering imbricated trails of root etching, the scientific data forces a singular, startling conclusion.
Yes. The only mechanism capable of producing those specific linear, parallel incisions is deliberate, repeated scoring with a sharp, hard implement handled by a human hand.
When you synthesize that data, the massive targeted disruption of the cranial base, which created a wide opening into the skull, combined with deliberate tool-made incisions on the interior surface behind the forehead, the archaeological interpretation becomes extremely clear. Shortly after she died, someone in her community used a sharp instrument to intentionally, methodically scrape out and remove her brain.
Excoriation of the brain. It is an astonishing finding, particularly because it requires significant anatomical intent and physical effort.
When we hear about brain removal in antiquity, our minds immediately go to the mortuary priests of ancient Egypt, right? Using hooked instruments through the nasal cavity during mummification to prevent putrefaction.
Right, that's the classic example.
But seeing this in Iron Age Scotland, in a community that doesn't practice chemical embalming, suggests an entirely different, highly specific cultural or ritual motivation. And yet the manipulation of her body did not end with the excoriation of her skull. The modifications to her postcranial skeleton are arguably even more complex.
Yeah, the researchers examined her long bones next. They recovered portions of both humeri, the heavy bones of the upper arm, her left ulna from the forearm, and her left femur, the thigh bone. It's important to note that these weren't complete bones. They were recovered as fragments representing roughly 50% of their original mass.
And when the site was originally excavated and quickly assessed back in 2000, the preliminary report suggested these fragmented long bones had been damaged by rodent gnawing.
Which is a perfectly reasonable initial hypothesis.
Sure. Rodents like voles and mice constantly need to gnaw to file down their continually growing incisors, and old bones are a fantastic source of calcium.
The rodent hypothesis makes sense at a macroscopic kind of quick glance level. However, the Comios project utilized highly advanced imaging to look closer. Rodent gnawing leaves an unmistakable signature: paired, parallel, shallow grooves created by the twin upper and lower incisors scraping across the bone surface.
Oh, like little track marks.
Exactly. When the researchers examined the fragments of the humeri, ulna, and femur, those paired incisor marks were completely absent.
Instead of rodent damage, the imaging revealed deliberate, systematic human craftsmanship. The exterior layers of the cortical bone, the hard outer shell, had been intentionally flaked and stripped away. Once the interior was exposed, someone had used tools to whittle and shave the bone shafts down, tapering them to distinct, sharp points.
Yes.
They literally carved her arms and leg into spiked implements.
To definitively prove this was tool work and not some bizarre pattern of natural weathering, the researchers utilized a technology called reflectance transformation imaging, or RTI.
RTI is an incredible tool. For listeners unfamiliar, it involves placing the artifact inside a dark dome equipped with dozens of individual LED lights. A camera takes a rapid series of photographs, turning on a different light for each shot.
It's a brilliant setup.
Software then synthesizes all those images to create a highly detailed, interactive 3D map of the surface topography. It allows archaeologists to manipulate the lighting angle digitally, casting microscopic shadows that reveal surface details completely invisible to the naked eye under normal lighting.
And when they applied RTI to the tapered end of the left humerus, the digital surface map revealed a distinct, microscopic U-shaped scar embedded right within the whittled margin.
And in the context of microscopic use-wear analysis, a perfectly symmetrical U-shaped gouge is the absolute smoking gun. Natural weathering or random rock abrasion cannot carve out a perfect U-shape.
Exactly.
That scar indicates that a very sharp, hard implement, likely an iron knife given the period, or possibly a specialized stone tool, was actively and forcefully driven into the bone to carve away the material.
The evidence of active tooling is indisputable, but the left femur fragment presented an additional fascinating detail. Unlike the humeri, which were whittled to sharp static points, the tapered end of the femur fragment did not terminate in a point.
What did it look like?
It terminated in a flat, highly smoothed, polished margin.
Which changes the interpretation entirely. If the edge is polished and flattened, it implies the bone wasn't just shaped to look like a tool, it was physically utilized as a tool.
Yes.
The polished wear pattern suggests the modified femur was repeatedly rubbed or worked against a softer material, like animal hide or perhaps textiles, creating that smooth friction wear over time.
The sequence of events is staggering. We have a woman who suffers catastrophic perimortem blunt force trauma to her head and shoulders. Immediately following her death, her cranium is opened and her brain is methodically removed. Her limbs are detached, defleshed, and the major long bones are aggressively whittled down into points, with at least one bone subsequently utilized in a physical task.
If the archaeological evidence stopped at that exact moment, the interpretation would be grim but straightforward. We would assume this was the ultimate expression of hatred and desecration.
Gosh.
In many cultures, when you want to truly obliterate an enemy, you don't just kill them, you dismantle their identity. You reduce their physical form to objects, denying them personhood in death.
Based purely on the physical mutilation, desecration would be the most parsimonious conclusion.
But the physical evidence does not stop there. The final stage of the mortuary process completely shatters the desecration theory. The great paradox of the Loch Borralie burial is how the archaeologists actually found these heavily modified, carved bones arranged within the grave.
What's fascinating here is that they were not scattered haphazardly. They were not discarded in a refuse pit. When the primary burial was uncovered, the whittled arm bones were placed back exactly where arms belong anatomically. The modified femur was placed exactly where a left leg should be.
They reassembled her.
Yes. They possessed the anatomical knowledge and, more importantly, the desire to reconstruct her physical form. She was laid out in that formal, extended supine position, oriented towards the east, and fastened into her burial shroud with the ring-headed pin.
This reassembly completely short-circuits our modern assumptions about violence in the body. If this were an act of nutritional cannibalism, the long bones would have been violently smashed open with heavy stones to extract the calorie-rich marrow.
Right, but they weren't crushed. They were carefully whittled.
And if this were the denigration of a despised outsider, the community would not have expended the time, the effort, and the intimate anatomical care required to piece her skeleton back together and lay her to rest with a shroud and tools.
The careful reassembly points in the exact opposite direction of denigration. It strongly suggests an intense level of community reverence and the prolonged, deliberate curation of her remains.
It's a completely different mindset.
Completely. Her body was not viewed as a biohazard or a taboo object to be quickly hidden in the earth. It was kept, it was intimately interacted with, it was transformed through tooling, and perhaps utilized in specific community rituals over a period of months or even years before finally being reconstructed and sealed beneath the primary cairn.
It fundamentally forces us to acknowledge that the Iron Age's conceptualization of the boundary between life and death and their relationship with the physical corpse was profoundly different from our own. It was a fluid, tactile relationship. We now understand the violent end of her life and the complex, reverent curation that followed. But to truly understand who these people were, both the woman and the teenage boy, we need to trace their lives backward. We need to look at their beginnings.
And to reconstruct their origins, the Kamios team shifted their focus from macroosteology to the microscopic chemistry locked inside their teeth, employing high-resolution multi-isotope analysis.
Anyone who follows modern archaeological science knows that isotope analysis has revolutionized our ability to track ancient human migration. But the specific isotopic signatures they pulled from the teeth at Loch Borralie presented the researchers with a massive, seemingly contradictory geographical puzzle. Let's break down the mechanics. How exactly does a tooth record a childhood address?
The key lies in the biological process of amelogenesis, which is the formation of dental enamel.
Okay.
When you are a child, your adult teeth are slowly growing and mineralizing within your jaw. As the enamel forms, layer by microscopic layer, it incorporates the specific trace elements present in your bloodstream. Those elements come directly from the food you eat and the water you drink.
So the enamel is literally building a permanent chemical ledger of your diet and environment.
Exactly. And unlike your skeletal bones, which are living tissue that constantly breaks down and remodels itself throughout your entire life.
Meaning your bones reflect the chemistry of where you lived in the last decade before you died, right?
Right. But dental enamel is acellular and inert. Once a tooth is fully formed in childhood, its chemical composition never changes. It is a locked vault. By sampling the second and third molars of the woman and the boy, The scientists were targeting the specific window of enamel formation that occurs roughly between the ages of 2.5 and 15.5 years old.
They are reading a barcode that tells them exactly what the local groundwater and soil chemistry looked like during those specific childhood years.
To read that barcode, the researchers looked at several different isotopes. First, they extracted dentine from the roots of the teeth to measure carbon-13 and nitrogen-15 ratios.
And what do those tell us?
These specific isotopes are dietary markers. They tell us where an individual sat on the food chain and the broad source of their protein.
And the dietary results for both individuals were highly conclusive, right?
They were. The carbon and nitrogen ratios indicated a diet overwhelmingly based on terrestrial C3 pathway sources.
In practical terms, what does that mean?
It means their protein came from land plants, grains like barley or emmer wheat, and terrestrial herbivores like sheep, cattle, or pigs. Crucially, the isotopic signature for marine protein, which is highly distinct, was virtually non-existent. They were not consuming fish, seals, or shellfish in any meaningful quantity.
Okay, so based purely on the carbon and nitrogen, you would assume these people grew up inland in a deeply agrarian or pastoral setting far removed from the ocean.
That would be the logical assumption.
Ugh.
However, the paradox emerges when we look at the strontium and oxygen isotopes extracted from the enamel. Strontium-87 and strontium-86 ratios in groundwater are directly determined by the underlying geological bedrock of a specific region. The strontium literally substitutes for calcium as the tooth forms.
So what did the strontium tell them?
The strontium concentrations were astronomically high. The adult female measured at 190 parts per million, and the teenage boy was at an incredible 264 parts per million. To put that in context, the typical baseline values for individuals living in mainland Britain range between 20 and 180 ppm. Values exceeding 1 in 90 are almost exclusively associated with specific coastal island environments, such as the Machair Plains of the Western Isles or the Orkney Archipelago. Furthermore, their sulfur isotope values hovered around 18 per mil, which is a definitive marker of living in immediate proximity to the sea.
This is the crux of the coastal paradox. The strontium and sulfur are screaming, "We live directly on the beach, breathing the ocean air." But the carbon and nitrogen are stating, "We never ate a single fish."
Yes.
So they lived right on the ocean but didn't eat fish. How is it possible to live your entire childhood on a rugged, windswept coastline surrounded by rich marine resources and survive purely on wheat and mutton?
It seems baffling until you understand the specific agricultural mechanics of extreme coastal environments. The high marine isotopic signatures in their teeth are not coming from eating marine animals. They are coming from a phenomenon known as the sea spray effect, combined with specific Iron Age farming practices.
Let's explore the sea spray effect. On a coastline like northern Scotland, the wind is a constant physical force.
Yes, and that persistent onshore wind constantly drives microscopic droplets of seawater, a marine aerosol inland. This sea spray, heavily laden with marine strontium and sulfur, settles on the coastal grasses.
I see where this is going.
Right. The terrestrial sheep graze on that grass, incorporating the marine isotopes into their meat and milk.
And the farming practices amplify this even further. Anyone familiar with traditional Scottish crofting knows the history of using seaweed, specifically kelp, to fertilize the sandy soil.
Absolutely. The Machair sand is well-drained but often nutrient-poor. Coastal communities heavily harvested seaweed and layered it onto their fields to boost crop yields, a precursor to the later lazy bed agricultural system. By artificially flooding their terrestrial fields with marine vegetation, they completely overrode the natural chemical signature of the local bedrock.
So, when the children ate the barley grown in the seaweed-fertilized soil and drank the milk from the sheep grazing on the salt-sprayed grass, their bodies absorbed massive amounts of marine strontium and sulfur, while still registering a terrestrial C3 diet from the actual proteins and carbohydrates. It is a stunningly precise piece of forensic deduction.
The isotopes definitively proved they grew up directly on a coastline utilizing marine fertilizer. The next challenge was pinpointing which coastline. The Scottish coast is immense.
Right.
To narrow it down, the team utilized the British Geological Survey's biosphere maps. This is an exhaustive database mapping the isotopic baseline values of groundwater and soil across the entire United Kingdom.
So by cross-referencing the strontium ratios with the oxygen-18 isotopes, which vary based on latitude, altitude, and rainfall patterns, the researchers could start systematically excluding vast regions of the map.
Exactly. The oxygen values allowed them to immediately rule out the milder, wetter regions of Western Britain. The high strontium values allowed them to rule out the deep inland valleys. Most importantly, the specific combination of isotopes allowed them to completely exclude the geology of the Durness Peninsula itself.
Which means the place where they were buried, Loch Borralie, was not the place where their adult teeth formed. They were migrants.
Yes. When the Kamios team ran the statistical models looking for the highest probability match for their specific, complex isotopic barcode, the data pointed to one highly restricted geographical area, an 80-kilometer stretch of the east coast of Sutherland, stretching roughly between the modern settlements of Helmsdale and Gulspie.
Let's map that journey. Helmsdale is on the east coast facing the North Sea. Loch Borralie is on the extreme northwest tip facing the Atlantic. We are looking at a migration of over 80 kilometers as the crow flies.
It's a massive trek.
That means at some point in their lives, after the age of 15, both the woman and the teenage boy traveled, either navigating the brutal tidal currents of the north coast by boat or trekking across the mountainous, boggy interior of the highlands to relocate to the Durness Peninsula.
And we return to the circumstantial puzzle. We have an adult woman and a teenage boy. They both spent their childhoods in the same specific 80-kilometer zone on the East Coast. They both migrated, perhaps together or perhaps sequentially, to the exact same location in the Northwest. They both died within the same specific chronological window between 50 BC and AD 70. And ultimately, their remains were interred together beneath the exact same stone cairn at Loch Borralie.
The narrative overlap is just too precise to be coincidence. The underlying question demands to be answered. Were these two individuals biologically related? Were they family?
Right.
And to answer that, the researchers deployed the most powerful, paradigm-shifting tool in modern archaeology, ancient DNA analysis.
Retrieving viable, readable DNA from human remains that have been subjected to 2,000 years of soil acidity, moisture, microbial attack, and temperature fluctuations is an immense technological hurdle. DNA molecules degrade and fragment over time, and the risk of contamination from modern humans handling the bones is incredibly high.
So to circumvent the degradation, geneticists don't just swab the bone surface. They target a highly specific, protected biological vault.
They target the petrous part of the temporal bone, specifically the tiny ossicles of the inner ear. The researchers sampled the malleus, a bone no larger than a grain of rice.
Why the ear bone?
The otic capsule surrounding the inner ear is the densest bone in the human body. Because its density is designed to protect the delicate mechanics of hearing, it does not remodel during life. And after death, its extreme density acts as a physical barrier. It locks the ancient DNA inside and protects it from exogenous environmental contamination.
The researchers drill into the malleus, extract the ancient genomic material, and begin sequencing. The first layer of data they extracted provided an immediate, compelling connection.
They sequenced the mitochondrial DNA, or mtDNA. Mitochondrial DNA is uniquely informative because it is inherited exclusively through the maternal line, from a mother to all her children. The sequencing revealed that both the adult woman, individual 1, and the teenage boy, individual 2, belong to the exact same mitochondrial haplogroup, T2b30.
Finding a matching haplogroup is interesting, but context is everything. If it's a super common haplogroup, it might just mean they belong to the same broad regional population.
Exactly. Context is key.
But
haplogroup T2b30 is not common. It is exceptionally rare. In fact, within the entire database of published ancient genomes recovered from Britain, this specific haplogroup is currently unique solely to these two individuals at Loch Borralie.
that level of rarity changes the statistical weight completely. It's the equivalent of having an incredibly obscure family surname. If your last name is Smith and you meet another Smith in a different town, the statistical likelihood that you share a recent traceable ancestor is pretty low.
Okay.
But if your family name is a highly specific hyphenated anomaly and you meet someone else with that exact name, the probability of a shared family tree approaches certainty. The shared T2b30 haplogroup effectively confirmed a maternal biological link. But the researchers needed higher resolution. They needed to know how related they were.
To determine the precise degree of kinship, the Kamios team utilized an advanced bioinformatic technique known as identity by descent, or IBD.
I think it's vital to differentiate IBD from the commercial ancestry tests people buy online. Standard admixture testing looks at broad allele frequencies to estimate regional origins, telling you that you are 40% Celtic or 60% Scandinavian.
Oh, totally different.
Identity by descent is a completely different mechanism. It doesn't look at broad populations. It looks for exact, contiguous, unbroken segments of DNA that are absolutely identical across the genomes of two specific individuals.
That is the perfect way to frame it. The length of those identical segments is the key to calculating time. When human beings reproduce, the genetic material from the parents recombines. In each successive generation, the long strands of DNA are essentially shuffled and chopped into smaller pieces.
It's like a game of genetic telephone. You start with a very long, highly specific paragraph of text. With every generation that passes, the paragraph gets chopped up, sentences are swapped, and the original block of text gets shorter and shorter. If you compare the genomes of two people and find a massive, perfectly intact paragraph of identical DNA, with absolute mathematical certainty that the message hasn't passed through very many generations, the longer the shared block, the closer the ancestor.
Geneticists measure the length of these shared IBD segments in a unit called centimorgans. The genomic analysis of the Loch Borralie individuals revealed that the woman and the boy shared over 43 centimorgans of identical DNA distributed across 4 distinct chromosomal fragments.
When you plug 43 centimorgans into the statistical models of genetic genealogy, what kind of relationship does that predict?
Given that they lived during the same chronological window and factoring in their shared rare maternal haplogroup, the most highly probable relationship is that they were second cousins.
Oh, wow.
This means they shared a pair of maternal great-grandparents.
So the narrative crystallizes. We are looking at a verifiable family unit. Second cousins who spent their formative childhood years in the same coastal region of Sutherland, who migrated across the highland terrain or the northern seaways, and whose lives ended on the Durness Peninsula, resulting in their interment in the same family cairn. That alone is a stunning reconstruction of prehistoric life.
But the power of identity by descent is that it can search the entire database of ancient genomes simultaneously. And when the computers scanned the broader map, the IBD algorithm found identical genetic fragments linking our Loch Borralie family to individuals buried at entirely different archaeological sites, separated by staggering distances and vast gulfs of time.
Here's where it gets really interesting. This is where the story explodes from a localized, intimate family tragedy into a map of a sprawling, multi-generational Iron Age dynasty. Let's trace the web. The IBD analysis first flagged a connection between individual 1, the adult woman whose brain was removed, and an adult male buried at an archaeological site known as Buh.
And the site of Buh is located in the Orkney Islands. Orkney is an archipelago situated off the north coast of mainland Scotland, across the infamously dangerous waters of the Pentland Firth. The geographic distance from Loch Borralie to Buh is roughly 175 kilometers to the northeast.
175 kilometers of ocean and rugged coastline. But the temporal distance is even more shocking. The radiocarbon dating for the man buried at Buh indicates he lived approximately 150 years before the woman at Loch Borralie.
We are looking at a biological connection spanning at least 5 or 6 generations. The man at Buh could have been a direct lineal ancestor of the Loch Borralie woman, or perhaps a close collateral relative of one of her direct ancestors. The genetic thread survived a century and a half of time and the crossing of the North Atlantic.
Okay, that's the woman's deep time connection. What did the IBD scan reveal about the teenage boy, individual 2?
The boy was also genetically tethered to Orkney, but his identical DNA fragments linked him to a completely different individual, buried at a site called the Knowe of Skye, which is located on the island of West Stray in the northern part of the Orkney archipelago. Furthermore, the individual at Knowe of Skye lived several decades after the teenager at Loch Borralie died.
So the family lineage was actively present in Orkney 150 years before the Loch Borralie burials, and it continued to thrive in Orkney decades after the Loch Borralie burials. And the web of connections does not stop there.
It expands down the west coast. When the geneticists ran the IBD analysis comparing the 2 Orcadian relatives, the man from Buh and the later individual from Knowe of Skye, they discovered that both of them shared identical DNA fragments with a third individual, an adult male buried at a site called Applecross.
Let's add Applecross to the mental map. Applecross is located on a remote peninsula on the west coast of the Scottish mainland, facing the Isle of Skye. It is roughly 140 kilometers southwest of Loch Borralie and nearly 300 kilometers southwest of Orkney. And this man lived contemporaneously with the Loch Borralie individuals.
When you plot these genetic hits on a map, you are looking at a vast, verified biological network. You have a family tree that stretches from the deep-sea lochs of the west coast at Applecross, up around the treacherous northwestern cape at Durness, across the open ocean to the northern islands of Orkney, and extending backward and forward in time across at least 2 centuries.
This genomic map completely detonates our traditional, often patronizing assumptions about prehistoric geography and social isolation. When we picture people living in the Iron Age, particularly in an environment as forbidding and mountainous as the Scottish Highlands, we tend to imagine them as deeply parochial.
Right, stuck in one place.
We picture small, isolated, terrified clusters of people huddled in their roundhouses, completely cut off from the world beyond their immediate valley.
That concept of isolated static populations is entirely dismantled by the DNA and the isotopic migration data. These families were not isolated. They were highly mobile, cosmopolitan maritime communities.
They were actively navigating the seaways. And we need to emphasize that the Pentland Firth, the strait separating Orkney from the mainland, is not a placid lake.
It was one of the most dangerous stretches of water in the world.
It is notoriously violent, featuring massive tidal races, whirlpools, and conflicting ocean swells. To maintain a biological network across that water requires highly advanced maritime technology, whether complex skin-on-frame boats or massive log boats, and an intimate generational mastery of navigation.
The sea was not a barrier that kept these communities apart. It was the superhighway that connected them. The ocean was their primary medium of travel, allowing them to periodically relocate, intermarry with distant kin, trade resources, and maintain deeply connected cultural identities over vast distances.
And the proof of that shared cultural identity isn't just hidden in their DNA, it's visible in the archaeological architecture of their deaths. Because when you look at how these specific genetically linked individuals were buried across these widely dispersed sites, a profound and highly specific pattern emerges.
Yes. If we collate the funerary context across the network, we have the stone cairn constructed over the bodies at Loch Borralie. At Boo in Orkney, the ancestor was interred within the accumulating rubble deposits of an abandoned collapsing roundhouse.
Okay.
At Know of Ski, hundreds of fragmented remains were found deposited into the rubble of a decaying architectural complex. And at Applecross, the relative was found beneath a cobble cairn constructed directly on the beach.
They are burying their dead within piles of accumulated rock, utilizing rubble and ruined architecture rather than digging formal subterranean graves.
In the past, archaeologists might have viewed burials within the rubble of old buildings as expedient, informal, or even disrespectful, like tossing a body into a convenient ruin.
Yeah.
But the genetic linkages provided by Camio's force a massive reevaluation.
It's intentional.
Highly intentional. These people were intimately connected by blood and maritime travel that suggests that depositing bodies into rubble and stone mounds is not an act of convenience. It is a deliberate, highly specific funerary rite. We're looking at a unified rubble cairn tradition.
It is the ultimate form of cultural maintenance. They are highly mobile, moving across hundreds of kilometers of ocean, but they are carrying their complex belief systems and their specific mortuary traditions with them wherever they go.
This genetic interconnectedness provides the missing human dimension to a long-standing archaeological debate. Throughout Atlantic Scotland during the Iron Age, we see a massive uniformity in material culture, specifically the construction of brocks, those massive, complex, dry stone towers that appear across the west coast, the north coast, and the islands. How does an incredibly complex architectural blueprint spread so evenly across such difficult terrain?
It spreads because the people are spreading. The architecture isn't just diffusing through random trade. It is being carried along the maritime superhighways by these specific, highly mobile, interconnected family groups. The DNA is the absolute proof of the human movement that carried the culture.
The synthesis of the osteology, the isotopes, and the ancient DNA from the Camio's project fundamentally transforms our understanding of these people from invisible, isolated figures into dynamic maritime navigators with profound, complex relationships to their ancestors.
The scale of the information extracted from this site is just breathtaking. Let's trace the arc of what we've uncovered today. We began with a single anonymous skull rolling out of a Machair sand dune in the year 2000. Through the rigorous application of modern science, we learned that this skull belonged to a 15-year-old boy, buried alongside his second cousin, a 30-something adult woman. We looked deep into the enamel of their teeth and found the microscopic chemical signatures of sea spray and kelp fertilizer, proving they spent their childhoods 80 kilometers away on the East Coast. We looked into the densest bone of their skulls and extracted identical fragments of DNA, mapping a sprawling multi-generational family dynasty that navigated the treacherous North Atlantic seaways to maintain connections from Applecross to Orkney over centuries.
And perhaps most evocatively, we examined the microscopic U-shaped scars and the radiating fractures of the woman's bones, revealing a story of catastrophic perimortem violence, followed by an intricate, highly ritualized postmortem process.
Right. Right. Her brain was methodically removed, her limbs were carved into tools, and yet her body was ultimately reverently reassembled in anatomical order within the family monument.
It is a stunning testament to the power of multidisciplinary archaeology to give voice to the archaeologically invisible. And if we connect this to the bigger picture, this deep dive deeply challenges our modern sensibilities. In contemporary Western society, we have aggressively sanitized the concept of death.
Oh, absolutely.
We remove the physical reality of the corpse from our daily lives. We delegate the handling of a body to professionals operating behind closed doors, and we seek to either place the remains deep in the earth or reduce them to ash as rapidly as possible. We treat the physical dead as a taboo, a finality that must be visually erased from the community.
We prioritize out of sight, out of mind. We want the closure of a sealed coffin.
But the evidence from Loch Borralie and the broader rubble cairn tradition demonstrates that for these Iron Age families, physical death was not the termination of the individual's presence within the community. The body of the Loch Borralie woman was heavily curated. It was physically modified, it was likely kept accessible, and it was interacted with through tooling and reassembly over a protracted period. The dead maintained a vibrant, compelling, and highly visible agency in the physical world of the living.
That brings us right back to the central contradiction of the site. When we first hear about cranial excoriation and bones whittled into sharp points, our modern instinct is to recoil. We categorize their treatment of the dead as bizarre, violent, or macabre. But I want to leave you with a final thought to mull over. If you look at the vast expanse of global human history, at the myriad ways different cultures have lived intimately alongside their ancestors, curating remains, maintaining tactile connections, and refusing to sever the physical bond between the living and the dead, are we actually the weird ones for wanting to bury our dead as quickly as possible and never look at them again?